This is practice problem number 1 for lesson 8, comparing relationships with equations. And in this problem, you're given the equation for the relationship between yards and miles. So converting miles to the number of yards. And that equation is that yards, the number of yards, are equal to 1,760 times the number of miles. And so remember that yards are smaller, much smaller than miles. So you need a lot more yards to measure the same distance. So if I'm measuring 1 mile, expect that this number of yards is going to be big. As a matter of fact, it's going to be 1,760 times the number of miles. And so if you have 1 mile, you multiply by 1,760. 5 miles, you multiply by 1,760 because the number of yards are 1,760 times the number of miles. Now, if you go the other way, the number of miles are going to be much smaller. So if you're measuring 3,520 yards, that number of miles is dividing by 1,760 or multiplying by the reciprocal of 1,760. So you're going to make this number much smaller to figure out the same number of miles you need to measure this distance. And likewise, it's the same for 17,600. So remember that yards are smaller than miles. You need many more yards to cover the same distance. You need 1,760 more per mile, or 1,760 times as many miles to get the number of yards. So 1 times 1,760 is 1,765 times. I broke this up. This is using the distributive property. 5 times 1,000, 5 times 700, 5 times 60. And you add these three together, you get 8,800. But to go the other way, now you're given the number of yards. And so how many miles is that? So you have to realize that every time you can take out 1,760 yards, that is equal to 1 mile. So how many times can you do that? That's division. You're dividing by 1,760, and that is 2 miles. 17,600, that's 10 miles. And notice that when you divide by 10, you get the same, no, I take that back. This is dividing by 1,760. So that is 1. So that is 10 times because it has the same digits. That's what I want to say. This is 1760. This is 1760. And then this is 10 times that. So the answer is 10 miles. This is a proportional relationship because every time you figure out how many yards are there per mile for each of these calculations, you always come up with that there are 1,760 yards per 1 mile. So that's a constant relationship. It does not change. So that's the constant of proportionality. It's a constant relationship. It is the key to this relationship being a proportional relationship. This is problem number 2. Decide whether or not each equation represents a proportional relationship. So here are the equations, and we're going to figure out whether or not it represents a proportional relationship by changing the form of the equation to see if I can get that form to be y equals kx. If I can get the equation into this form, then it is a proportional relationship. That would mean that y changes in a constant way compared to x, just by multiplying by whatever the value of k is. If I cannot do that, then it is not a proportional relationship. So in this first one, A, I'm going to change L to y. So it's just y equals 120 minus x, and I want to see if I can get this into the form of y equals kx. And it turns out that I cannot do that. Y equals 120 minus x. I'm just flipping this over the equal sign. That's not y equals kx. And there's nothing I can do. I can't change this subtraction to multiplication. Now I can rearrange the terms. This is called a term, and this is called a term. And so I can rearrange them and put the x as the first term. And the way that I do that is I change this to addition. So 120 plus, and then the additive inverse of a positive x is a negative x. And a negative x is negative 1 times x. It means the opposite of x. So I can change the operation to addition, so the inverse operation, and using the additive inverse. Now I can use the commutative property to switch the order. So now I have y equals a negative 1x plus 120. And this is kind of getting closer, but it's still not y equals kx. And if I plugged in a number of values for x equals 1, x equals 2, x equals 3, and calculate the value of y, and you can do that, and it'd probably be a good activity or a good exercise to do that for a few values. You're going to find that when you take the answer, the value for y, and divide that for whatever you use for x, it is not going to be constant because it is not a proportional relationship. So A is not a proportional relationship. B, on the other hand, is. It says the total cost T after an 8% sales tax is added to an item's price. Now you might get confused because they're saying the sales tax is added, but the way you add tax is you use multiplication. So you add 8% tax as you multiply by 8/100ths, that is 8%. So this is 1, that's the cost of the item, and then you're adding or plus 8/100ths. So this is 1 and 8/100ths times whatever the price is. So don't get confused. You are actually multiplying by 1 and 8/100ths as you add an 8% sales tax. And so this, you can get into that form. I'm going to change t to y and p to x. And so y equals 1 and 8/100ths times x. So yes, 1 and 8/100ths times x is in the form of y equals kx. So no matter what value, no matter what the cost is, what the price of the item is, the cost, the total cost is going to be the total cost compared to the price. So t divided by p, or y divided by x, is going to be 1 and 8/100ths. It's going to be a constant amount. It's going to be a proportional amount. So this is a proportional relationship. All right, the number of marbles each sister gets x when m marbles are shared equally among 4 sisters. So shared equally is dividing the number of marbles up into 4 equal parts. That's the same as multiplying by 1/4. So dividing by 4 is the same as multiplying by 1/4. So m is the number of marbles. So I'm going to take 1/4 of the number of marbles, which is the same as dividing by 4, and I'm going to give that amount to each sister. So I'm going to put this in the form of y equals kx. So x is going to be y, sorry about this, and m is going to be x. So this is y equals 1/4 x, and so yes, that is in the form of y equals kx. So whatever value I use for x, I take the value I get for y. If I divide that by x, I'm always going to get 1/4, because this is y divided by this x equals 1/4. This goes back to how we were writing equations in the beginning. Y equals kx. So so the constant amount is 1/4. That is the constant proportionality. It is a proportional relationship. So D is looking at the volume of a rectangular prism whose height is 12 centimeters, and its base is a square with side lengths equal to s. So the volume is equal to 12 times the area of the base. So s squared is the area of the base, and then that rectangular prism is going to be 12 centimeters high. No matter what the area is, it's always going to have a height of 12 centimeters. You might think that that's a proportional relationship because that 12 centimeters height is constant. That does not change. But the area does change. The area is not a constant amount, and it's not in a proportional relationship with the volume. So I can kind of get this close. If I change the volume to y and the side length to x, I can write this as 12x times x. This is the area right here, x times x, but that is not constant. This 12x, see how this 12x is going to change with each value of x. So that's not constant. This is not a constant amount. So it's not a proportional relationship because you cannot get this in the form of y equals kx. To be proportional, this amount right here has to be constant. It cannot change. So that when you figure out the total volume in this case per the length of side, if that were always constant, then it would be a proportional relationship. But in this case, it is not, because this 12x changes with each value of x. So no, it is not a proportional relationship. This is problem number 3. And in problem number 3, there is 2 parts, an A and a B. And in the A part, you're given the equation y equals 5/2 x. Asked to fill in this table and asked to explain whether this is a proportional, whether y is proportional to x or not, and explain why or why not. So first of all, fill in the table. So for each value of x, then y is 5/2 that amount. So 2.5 or 5/2 times 2, 5/2 times 2 is equal to 2 times 5 is 10. 10/2 is the same as 5. So these 2's cancel out, or you can multiply it. 5 times 2 is 10/2. So it's either 5 or 10/2. If x is 3, that's 3 times 5/2. So that's 15/2, and you can also simplify that to 7.5. So 15/2 or 7.5. And if x is 6, 6 times 5/2, well, that 6 can be factored out to 2 times 3. The 2's can cancel out. 3 times 5 is 15, or 30/2. And certainly 30 divided by 2 is also 15. So is this a proportional relationship? Well, a way to figure that out, first of all, you can tell that it is from the form of the equation. Every time you choose a value for x, y is then 5/2 times that amount. So you're always multiplying by a constant amount. So y is always 5/2 larger than x. And so then if you figure out what's the number of units of what's the amount of y per 1 unit x, then you divide y by that x. So what's the amount of y per a single unit of x if x is 2? Well, that's 5 divided by 2. If x is 3, well, that's 7.5 divided by 3. You're figuring out what's the number of units of y per a single unit of x. If x is 15, if x is 6 and y is 15, then you take the 15 and you divide it by that 6. That tells you how many units you have per a single unit of x. And in every case, that answer is 5/2. So y divided by x is 5 divided by 2. So that's 5/2 or 2.5. 7.5 divided by 3, or 15/2 divided by 3. So it's easier for me to work with this as the fraction. That's 15/2 times 1/3. That's 15/6. Well, 15/6 is 15 is 5 times 3. These 3's cancel, you get 5/2. Or 30/2 times 1/6. 30/2 divided by 6. 30/2 times 1/6. 30 is 5 times 6. These 6's cancel out, and you get 5/2. So you should practice this idea of working with the fractions. You're always going to get 5/2. So what that means is no matter what amount of x you have, you're going to calculate y as multiplying by 5/2. x by 5 halves. And then when you figure out how much is the value of y that you have per single unit x, you do that division, and you're always going to get a constant amount, this 5 halves. So this is a proportional relationship. When I divide y by x, the answer will be a constant amount, showing that y is proportional to x by that constant. It's a constant of proportionality. So the equation is in the form y equals kx. So to get y, x is multiplied by k, which in this case is 5 halves. So y divided by x will always equal that constant. So to get y, you're multiplying by 5 halves, while y divided by x is always going to give you that 5 halves because you multiplied by 5 halves. So k is the number of units of y, the total amount of y per single unit x. That's what happens when you divide something by x. That's telling you how much there is per 1 unit. And that's always going to be k. It does not change. It is called the unit rate. How much do I have per unit x? What's that unit rate? And that unit rate is also called the constant of proportionality. In this case, it's 5 halves. On the other hand, if you have an equation in this form, this is more than y equals kx, you add 5 to that. So you always go back and add 5. This is the proportional part, y equals 3 2/10 times x. But then you always go back and add 5 to it, regardless of the value of x. So this relationship, this ratio of y divided by x is always going to change. It's not going to be a constant amount because you're always adding this 5 to that. So fill in the table by plugging these values in for x, 1, 2, and 4, 1, 2, and 4, multiply by 3 halves, and then go back and add 5 to that. So you make all those calculations, you get 8 2/10, 11 4/10, and 17 8/10. And you should practice making these calculations. They're not bad. 2 times 3 2/10 is 2 times 3 is 6, 2 times 2 is 4/10. 4 times 3 is 12, 4 times 2/10 is 8/10. Not too bad. Then add 5 to them, and then calculate what's the amount of y per single unit x. So the first one is 8 2/10, because there's only 1 unit of x. But now there's 2 units of x. So what's the amount of y per these 2 units? We have to divide by that 2. So this is going to be 5 and something, because it's a little bit more than 10. So 10 divided by 2 is 5. This one is going to be 16 divided by 4 is 4. So this is going to be a little bit more than 4. So you take this amount of 17 8/10, and you divide it among these 4 units of x to figure out how much do you get per single unit x. If that's a constant amount, then this is a proportional relationship. But we know in this case it's not a constant amount, because you're always adding this 5. So 8 2/10 divided by 1, 11 4/10 divided by 2, and 17 8/10 divided by 4. So I went into this a little bit more detail. You can look at this as 16 fourths plus 1 8/10 fourths. 16 divided by 4 is 4. 1 6/10 divided by 4. So 16 divided by 4 is also 4. But in this case, it's going to be 4/10, and plus 2/10 divided by 4. A little bit tricky here. So this is 4 plus 4/10 plus 2/40. So I'm going to multiply this times 10 and this times 10. So this is 2/40. So this is 4 4/10 plus, and 2/40 is the same as 5/10. And this is a little bit tough. There's probably an easier way to do this. Not seeing it right now, but so 2/40, divide each of these by 4, you get 5/10, which is 5/10 is 5/100. So 4 4/10 plus 5/100 is 4 45/100. Anyway, the point is that this is not a constant amount. It changes. So when the values for x change, the amount of y per single unit x also changes. So it's not proportional. It's not a constant amount. So y is equal to 3 2/10 x plus 5 cannot be written in the form y equals kx. Therefore, y divided by x, or the amount of y per single unit x, will not be constant. As shown, y is not proportional to x. There is no constant amount of y per unit x. So it is not a proportional relationship, no constant proportionality, no single unit rate. So it's not proportional. This is problem number 4, and this problem has to do with moving information on the internet, so transmitting information or moving it along the internet. So what are the units that information is measured in? So if I want to know how many units of information I'm moving, I need to know what that unit is. And there are 2 units, actually 3 units, but we're going to begin with 2 types, 2 sizes of things, 2 units that are used to measure information. One is a packet and the other one is a byte. And it turns out that a packet, what you have to realize in looking at these problems, is what is the larger unit and what is the smaller unit. And this relationship tells you that they tell you right here, each packet has 1,500 bytes of information. So a byte is much, much smaller than a packet. So if I'm going to measure an amount of information as one packet, that one packet is going to equal 1,500 bytes. And so the equation that relates those two pieces of information is that the number of bytes is equal to 1,500 the number of packets, because if I have one packet, I have 1,500 bytes of information. So P represents the packets, the number of packets, and B represents the number of bytes. So the main idea here is to realize that bytes are smaller than packets. So you need a whole lot of bytes to get the same amount of information in packets. So how many packets would you need to transmit 30,000 bytes of information? So now realize that the number of packets is going to be much, much smaller than the number of bytes. So this answer, how many packets, is going to be a small number compared to the number of bytes, because every time I can take out 1,500 bytes out of this 30,000, what does that equal? That equals a single packet of information. So 30,000 bytes, the number of bytes is equal to 1,500 times the number of packets. So I have 30,000 bytes. Every time I can take out 1,500 bytes, that's equal to a single packet. So how many times can I do that? Well, that's multiplying this 30,000 times the reciprocal of 1,500. So this 1,500 is the constant of proportionality. But now we're going backwards. We're going the other way. We're going towards figuring out the number of bytes that this equals. We're going towards figuring out the number of packets that this equals. So you have to multiply by the reciprocal or divide. That's the same as dividing by 1,500. So once again, every time I can get out 1,500 bytes out of this 30,000, that is equal to a packet. And how many times can I do that? Here's 30 divided by 15 right here. That's 2, but this is 10 times that. So the answer is going to be 20. So this has 20 packets of information. So 2 packets of information would be 3,000. So 20 packets of information are going to be 30,000. All right, so then B, it says how much information could be transmitted in 30,000 packets. So now I have 30,000 of these big things. So how much information in terms of bytes are transmitted in those 30,000 packets? Well, so now this number, this answer for bytes is going to get much, much, much bigger, because you're going to multiply by 1,500. So you take the number of bytes, it's going to be 1,500 times the number of packets. So this number of bytes is going to get to be huge. So what I did here is I pulled out the 3 times 15. So 3 times 15, this is 15 hundredths. So 15 times 100, and this is 3 10,000ths. So 3 times 10,000. So you can pull out, these are called powers of 10. So you can pull out the power of 10 of 100 and the power of 10 of 10,000 and multiply the 3 times 15 is 45. And 10 times 10,000 is 100,000. And 10 times 100,000 is 1,000,000. Or 100 times 10,000 is 1,000,000. So you end up with 45 million. So this is 45 million bytes of information in 30,000 packets. So once again, notice how big this number, the number of bytes, gets compared to the number of packets. And if you went backwards, you started with 45 million bytes. How many packets would that be? Well, you would divide by 1,500. You divide by this and figure out, gee, I get 30,000 packets. Then if I divide this number by this 1,500, which is the constant of proportionality. All right, so now they're going to give you more information, which is they're going to take a byte and break that up into 8 smaller pieces. And those smaller pieces are called bits. So each byte contains 8 bits. And this gets confusing. You have to think carefully through this. So we're going to start out with a byte, b, and that equals 1,500 times the number of packets. So the number of bytes equals 1,500 times the number of packets. Now t we're going to use for bits. And t, the number of bits, is equal to 8 times the number of bytes. If you have 1 byte, then you have 8 bits. So bits are smaller. So the number of bits to equal the same amount of information is going to be a bigger number. It's going to be 8 times whatever number of bytes you have. So how many says, write an equation to represent the relationship between the number of packets and the number of bits. So we're skipping over the number of bytes. All right, so change the number of bits. Change the number of bytes to the number of bits. So for every byte, you get 8 bits. So if I have 1,500, if the number of bytes is 1,500 times the number of packets, then the number of bits is going to be 8 times that. So for every one of these bytes, and there's 1,500 of them, I have 8 bits. So I have 8 times 1,500 of these for 1 packet. So that means that the number of bits is equal to 12,000 times the number of packets. So if I have 1 packet, I have 12,000 bits. So 1 packet is equal to 1,500 bytes equals 12,000 bits. And it's confusing because the terms are kind of funny. If you said it quickly, it becomes comical to talk through this. For me, the best way to understand this is to make a drawing. So I did that where I made a drawing of a single packet. So what does a single packet look like? Well, in that single packet are 1,500 bytes. Now I couldn't draw 1,500 of these circles, but imagine that there are 1,500 of these circles. And each one of these bytes has how many bits? Well, each byte has 8 bits. So this is 8 bits for each one of these bytes. So now you can see that is 8 times these 1,500. So 8 times 1,500 equals 12,000 bits for 1 packet. So the number of bits is going to equal 12,000 times the number of packets. So back to this equation, the number of bits equals 12,000 times the number of packets. There's a whole lot of bits in one packet.